Here we go, acting 3.
Hello, we're students from Harmony Science Academy, Carrollton. My name is Lena.
My name is Jennifer, and the name of our experiment is Dealing with Diabetes, the Road to an Artificial Pancreas.
The idea behind this experiment is similar to the insulin pump that people currently have. The artificial pancreas would be different because it would be automatic and would be doing the work for the person, rather than them having to watch for their blood sugar levels constantly, even as a child. This way it ensures the health of those who need it. In our experiment, we are creating a simple version of what would be happening in a real artificial pancreas that could work in a person's body.
During the length of our project, we kept a journal as our English component. For further information, please look at our Google Sites.
For the social studies component of our PBL project, we looked at the economic influence of an artificial pancreas. For more information, go to our website. The materials we used in this experiment were a digital scale with 0.1 gram increments, a graduated cylinder of 100 milliliters or 250 milliliters of volume, a piece of plastic that can float, a bendable plastic drinking straw, a box of baking soda, a weighable or some other small container to use for weighing baking soda on the scale, a bottle of distilled white vinegar, a gallon of distilled water, some beakers that will be shown later, and a permanent marker. We also used a solderless breadboard, a 330 kilo ohms resistor, a 100 kilo ohms resistor, a jumper wire kit, an N-channel MOSFET, a 1 mega ohms potentiometer, a 100 kilo ohms potentiometer, a 10 kilo ohms potentiometer, 4 alligator clip test LEDs, 1 battery holder for 8 AA batteries with wires, 8 AA batteries, 24 AWG bare copper wires, a Rothmel blue indicator solution of 0.04%, and a 12-volt peristaltic liquid pump.
With the solderless breadboard, first we have to put in all the resistors as well as the other components. An exact procedure can be found on our Google Sites. Here is a picture of what you should end up with. Here we begin by setting up all the electricity components. Here I am connecting the battery as well as the pump to the solderless breadboard. This is how it should be looking like when it is finished. Right now we are putting it to the artificial pump. This is whenever it's going to start moving, and you will see it shortly. Here is the part of the pancreas where it will be set into the liquids. You also need to connect this to the solderless breadboard. Here you have to wrap the wire to the electrical component so that the electricity can pass through.
Our next step was to make all the solutions that we'd be using to show the process of glucose and insulin. We made 3 different solutions. One was completely vinegar, one was vinegar and baking soda with water, and the last one was baking soda and water. Make sure you carefully mix the baking soda and vinegar because there will be a chemical reaction. And in the images here, you can see the Rothmel blue is in the solution, turning them blue, dark yellow, and light yellow.
Once everything was ready, we were able to test the pancreas by putting the straw part in one solution and the tubing in another solution. Then the pump kept moving the liquids around, showing the color changes. The different color changes showed how the artificial pancreas would be able to work in the human body. We employ both engineering and scientific principles in order to create an artificial pancreas that would be entirely mechanical. The process that we are doing is something that biomedical engineers are currently working on. They are trying to manufacture a pancreas that would be able to replace a faulty pancreas as well as an insulin pump.